Solving quadratic equations. When solving linear equations, so those are equations like 2x plus 3 equals 5. The aim is to get all the unknowns to one side and the numbers on the other. But this isn't true for quadratic equations. So the most important thing with quadratic equations is they must equal 0 first of all. Then we factorise each side, let each factor equal 0, and then that produces a solution. If the quadratic equation isn't equal to 0, there are an infinite number of possible answers. So making it equal to 0 reduces this to 2. So if you were to think of if A multiplied by B was equal to 4, so you could have 2 and 2, you could have 4 and 1, you could have 8 and a half, you could have 40 and a tenth, and there are an infinite number of combinations of those to do that. However, if you were to make it that A times B equals 0, then what must be true is that A is 0, or B is 0, or both are 0. Those are the only conditions that we have. So we're reducing the number of possible answers from an infinite number down to 2. So in example 10, we've got equations that have already been factorised for us. So example A, we've got x plus 4 upon x plus 5 equals 0. So what we do is we let each factor equal 0. So either x plus 4 must equal 0, or x plus 5 is equal to 0. And if x plus 4 equals 0, if we take 4 from both sides, or move the 4 over, we get x equals minus 4. And similarly with the plus 5, we get x equals minus 5. And that's our solution. So we've solved x plus 4 upon x plus 5 is equal to 0. Example B, x minus 3, x plus 2 equals 0. Again, let each factor equal 0. So we'll have x minus 3 is equal to 0, or x plus 2 is equal to 0. If x minus 3 equals 0, if we move the 3 to the other side or add 3 to both sides, we get x is equal to 3, and similarly we get x equals minus 2. So the answers there are x equals 3 or minus 2. And finally, example C then, we've got x upon x minus 7. This looks slightly different to the previous two, but it's still in a factorised form. X is a factor and the bracket is a factor. So again, we let each factor equal 0. So that's going to be x is equal to 0, or x minus 7 equals 0. We don't need to do anything to the first one because we've got an x value. Whereas the second one, add 7 to both sides, move the 7 across, and you get x equals 7. So the answers for C would be x equals 0 and 7. Example 11, solve part A, x squared plus 10x minus 24. So the equation equals 0, that's the first thing we need to check. Then we need to factorise it. And to do this, we'll use sum and product. So the sum is 10 and the product is minus 24. The two numbers that add to 10 and multiply to minus 24 are going to be 12 and minus 2. Now this is a case where it's simple quadratic factorising because the coefficient of x squared is 1. So we can go straight to the brackets. So we'll have x plus 12 and x minus 2 is equal to 0. We then let each factor equal 0. So x plus 12 must equal 0, or x minus 2 is equal to 0. So if x plus 12 is equal to 0, then x equals minus 12. And if x minus 2 equals 0, x equals positive 2. So the answers there are x equals 2 or minus 12. Part B, again, the equation is equal to 0. So that's the first thing we need to check. Then we need to do our sum and product. The sum is 3, so the number before the x, The product then is not minus 20 because it's a 2x squared. So the product is minus 40. So we need to come up with two numbers that add to 3 and multiply to minus 40. And that's going to be 8 and minus 5. Because it's 2x squared, we have to use the longer method of factorising, the 4 terms. So we've got 2x squared plus 8x minus 5x minus 20 equals 0. Split them into their pairs and perform simple factorising. So we've got 2x upon x plus 4. Repeat the bracket. And outside the second bracket, to get from x to minus 5x, from 4 to minus 20, we need to multiply by minus 5. So we get 2x minus 5 upon x plus 4 is equal to 0. Then we let each bracket equal 0. So 2x minus 5 equals 0, which will lead to 2x equals 5. So x equals 2.5. Or x plus 4 equals 0, which leads to x equals minus 4. So our answers there are x equals 2.5 and minus 4. Example C is 5x squared minus 6x equals 27. The first thing we need to do is check, does the equation equal 0? And this time it doesn't. So we need to bring the 27 over, and we get 5x squared minus 6x minus 27 equals 0. The sum, so we need to do factorising, and it's the more difficult form of factorising because it's 5x squared. So the sum is minus 6. The product is minus 135. So we need to come up with the two numbers that multiply together to give minus 135 and add together to give minus 6. So they're going to be 9 and minus 15. We have to do our 4 terms form of factorising. So we're going to have 5x squared plus 9x minus 15x minus 27 equals 0. Split them into their pairs. Perform simple factorising. So we'll take out an x, and inside is 5x plus 9. Repeat the bracket, 5x plus 9, and we need a minus 3 outside it. So we'll have then x minus 3 upon 5x plus 9 is equal to 0. We let each factor equal 0. So x minus 3 equals 0, which will lead to a solution of x equal to 3. And if 5x plus 9 equals 0, 5x equals minus 9. So x is going to equal minus 1.8. So those are our two solutions, minus 1.8 and 3. Example D, x squared minus 5x equals 0. So here we've got an example where it is equal to 0. So that's the first check, remember? That's good. Then we need to do factorising. Now this is 2 terms, so you think, is it sum and product? Well, no, it's not that because there's no product. Is it the harder sum and product? No, it's not 4 terms. X squared is a square number, we have a difference, but then 5x isn't a square number. So I'd say what this is just a case of simple factorising, so common terms, just like we had in the 4 terms where we had 5x squared plus 9x, and that went to x upon 5x minus 9. This is just common terms. So what we can do is we can take out an x, and it's going to be x upon x minus 5 equals 0. So the first factor of x must equal 0, or the second one, x minus 5 equals 0, which leads to a solution of x equals 5. So the answers there are x equals 0 and x equals 5. Example E, we've got x squared minus 16 equals 0, so the equation equals 0, that's good. Then we need to perform factorising. Now x squared is a square number, 16 is a square number, and we've got the takeaway, so that means we're going to use the difference of 2 squares. So we've got 2 brackets, one's a plus, one's a minus, and each term in the bracket is the square root. So the square root of x squared is x, and the square root of 16 is 4. So we get x plus 4x minus 4 equals 0. So then x plus 4 is equal to 0, which is gives us a solution from x equals minus 4, or x minus 4 is equal to 0, which means x equals positive 4. So x equals plus or minus 4 there are your two solutions. Part F looks a little bit different. So what we need to do for this, or there is another way to solve this, and that would be if we have x squared minus 16 equals 0. If we move the 16 to the other side, we get x squared equals 16. And then if we take the square root of both sides, we get that x equals the square root of 16. So x would equal 4. But we've missed out on a solution there. We just worked out that x would equal plus or minus 4, and we've just got the 4. And the reason for that is whenever we take the square root of 16, we should know that there are two solutions for there. So 4 times 4 is 16, but minus 4 times minus 4 is also 16. So what we can do is we should write it as plus or minus the square root of 16, which then gets us to plus or minus 4. So using that same result, we can do that in F. So what we have in F is something squared, take away 10 equals 0. So we could take the minus 10 to the other side, and we get x minus 1 squared equals 10. Then we can take the square root of both sides, so we get x minus 1 equals plus or minus the square root of 10. Now, using our surds, we can't simplify that in any way, so it's just plus or minus the square root of 10. So then x is going to equal 1 plus or minus the square root of 10. So moving the 1, minus 1 over, it becomes a plus 1, and then we've got this plus or minus square root of 10. We could put that into a calculator and get the two answers, or we could leave it in this form, which would be the exact form. If we were to approach this question differently and think, well, actually, I want to expand the brackets first of all. So we would have x minus 1 multiplied by x minus 1, take away 10. So using FOIL, first together, outer, inner, last, we get x squared minus x plus 1 take away 10 is equal to 0. Collecting terms, we get x squared minus 2x minus 9 is equal to 0. And then we would go about our sum and product. Now the sum here is minus 2, the product is minus 9. The things that multiply together to give minus 9 would be 9 and minus 1, or minus 9 and 1, 3 and minus 3, or minus 3 and 3, and none of those combinations will ever get to minus 2. So had we gone through the expanded brackets, we wouldn't have been able to solve that equation yet. But in the next video, we'll look at how we would do that.